We're going to finish up the chapter looking at what are called measures of position. Basically, this is a way of trying to get a handle on, where a data value falls compared to the rest of the data set. And we'll start with what are called Z-scores. Z-scores give a relative position of a data value compared to the mean of the data set and allow comparison of data values from separate distributions based on those relative positions. The Z-score is the number of standard deviations that a given value of X, a data value, has above or below the mean. So we calculate Z-score by X minus X bar over S. Again, X bar is the mean, S is the standard deviation. We do this one for a sample. We do this one for a mean. Little typo there. There should be no bar over the mu. It's just X minus mu over sigma for a population. We round the Z-scores to 2 decimal places because generally we will look at, later on, we will look at tables that go to 2 decimal places. Ordinarily, data values have Z-scores that are less than or equal to 2 standard deviations. Unusual outlier data values are outside of this range. If the data value is less than the mean, it is negative. And again, the negative sign just means that the relative position is less than the mean. A positive means the relative position is above the mean. Okay, percentiles. Percentiles are the relative position of the data value compared to the entire data set. When you divide it into 100 groups, each group is about 1%. A data value at the 60th percentile has about 60% of the data below and about 40% above it. The percentile of X equals 100 times the number of data values below X divided by the total number of data values. To go from a percentile to the corresponding data value, reorder the data values from lowest to highest and then compute L equals K over 100 times N, where K is the percentile and N is the number of values. Now, here's the tricky part. If L is a whole number, so when you calculate this, and L is a whole number, then you're going to average the value you got and the one next to it in the data set to find the value of the percentile, pK. If L is not a whole number, then we're going to round it up, and pK, that percentile of that K, will be the Lth value of the data set. And we will look at some examples of how to do that shortly. Quartiles are dividing the data set into 4 parts. Q1 is the same as the 25th percentile. Q2, the 50th percentile. Q2 is also the median. Q3 is the 75th percentile. And then we can have what's called the interquartile range, which goes from Q3 down to Q1 or Q1 up to Q3, depending on how you do it. And we can also look at a little diagram here, which is a diagram of a box plot. But right in here is the IQR, the interquartile range, going from the first to the third. It's another way of thinking of this is the middle half of the data. Outliers are data values that are above Q3 or below Q1 by an amount greater than 1.5 times the IQR. Outliers are marked by dots or asterisks beyond the line, but in line with it. So if we had some outliers, they would be, maybe out in this range or down in this range if they were more than 1.5 IQRs from the middle there. So let's look at finding some of these. So first off, we want to find the Z-scores of the following data values if the mean is 43.8 and the standard deviation is 8.9. Now, in general, they will give you these things, but it is possible to have a problem in which you get some data values and you first have to determine what the mean and standard deviation is before then you could go find a Z-score. So We want to know what the z-score is for 38. So again, here's our formula for a sample, x minus x bar over s, So 38 subtract the 43.8 divided by the 8.9 gives us a negative 0.65. Again, we're going to always round this to 2 decimal places. The negative means that this is below the mean. It does not mean less than 0, it just means it's below the mean. Okay, over here we're going to look at 61. So 61 subtract 43.8 divided by the 8.9, and we get a z-score of 1.93. In other words, this is almost 2 standard deviations above the mean. And so some examples of finding z-scores. All right, now let's look at finding some other types of positions. So we have a data set here. There are 24 values in the data set. And the first thing we want to do is find the percentile of 47. So here's the 47. It's in our list. We want to know what percentile it would have. Basically what you're asking in that case is what percentage of the entire data set does the 47 fall above? So 47 is the 10th data value. If you just count across, it's the 10th one. So our percentile would be 100 times 9 out of 24. Notice it's 9. It's the 10th value, which means it's above 9 of them. So 100 times 9 over 24 gives me 37.5. And so the 47 is at about the 38th percentile. Now, going in the opposite direction, let's find which one of these is at the 70th percentile. So, using the L equation here, for P70, notice 70 here, 70 there. So 70 over 100 times 24, we get to 16.8. We round the 16.8 up to 17, and so we want the 17th value. So if we count across, the 17th value is 57. So the data value of 57 is above 70% of the data values in the list. That's what we're saying when we do percentiles, is at this point you're above that much of the entire data set. So a couple more examples now. Let's find out the percentile of 65. I've gone ahead and reprinted the list there. So here's the 65 over there. It's at the 21st position. So it is bigger than 20 data values. So again, the percentile for the particular data value will always be one less than its position in the data set if it's ordered from smallest to largest. So 20 over 24 times 100 gives us 83.3, so the 65 is at about the 83rd percentile. Now, interestingly, since there are only 24 values in this data set, you're not going to get exactly, the 20th percentile and 21st percentile and 23rd percentile and so forth, because there are only 24 total here, so it will be an approximation. Very often, though, there might be hundreds or even thousands of data values in the set, in which case you can get very, very close to, being 83% of the data would have been less than data value 65 here. This is very common when people would take their standardized tests, and you would find out that what percentile you were in, and basically you didn't know what your score was, you just knew how your score compared to everybody else's score. Alright, so here we're now wanting to find Q1. Remember that Q1 is the 25th percentile, and so with our L equation here, 25 over 100, there were 24 data points, so we come out with a 6. Notice that this time we've come out with a whole number, and so what we have to do is take the 6th and the 7th ones, so 1, 2, 3, 4, 5. So 41 is the 6th, 43 is the 7th. We're going to average those two and come out with 42. And so if we consider the number 42, which would fall right between these two, it's going to be above 6 values, which is 25% of the data, and it's going to be below 18 values, which is 75% of the data. Even though 42 is not actually in the data set, that particular number would fall at the Q1 position. Alright, and finally we're going to look at how to construct a box plot. And we need 5 numbers to construct a box plot. First off, we need the minimum value, which would be the lowest value in the data set. This is not the same data set we used before. This is the entire data set here. We have a maximum value of 79, so that will be our last point on our box plot. And then what we need is Q1, Q2, and Q3. And again, Q1 is the 25th percentile, Q2 is the 50th percentile, which is the median, and Q3 is the 75th percentile. And so we find out that Q1 comes out at 2.5, which if we round up to 3 means we need to take the third data value for our Q1, so that would be the 39. The 50th one, we came out 5, and in other words, this is just like doing median. There are actually 10 data values here. So when we put them in order and split them in half to find the middle, well, it turns out that since it's even, we have to take the 2 middle values, the 51 and the 53. A little typo there, it didn't come out, but the 51 and the 53, put those two together, and then we'll get 52, and so our second quartile is 52. And then in the third case, we got 7.5, rounded up to 8, so the 8th data value was 63. And now we can make our box plot. Now, if you are doing this by hand, I'm not that worried about you using a ruler and everything perfect, but it should kind of represent the numbers in your data set. So we're going from 34 up to 79. So, 52, which is the median value, needs to be, in the middle of these two. Now, that does not mean necessarily halfway in terms of how these have been stretched out, because it just means that half the data values are down here and half the data values are up there. And then here we have our Q1, 39. Here we have our Q3, 63. Draw a little box. And basically, the point of the box plot is it gives us a visual picture of the way the data has been laid out. And so, measures of position.